Okay, thank you all for being here. Today we're gonna start with unit testing and the significance and importance of unit testing. First of all, unit testing is best to understand that unit testing is what every software engineer use to help improve their software system in the business. So I'll start by defining what unit testing is. And unit testing is the process of examining a small piece of software to verify that it meets the rules asserted. It meets the business rules. So this means is that unit testing is kind of like you take a small piece of software, then you take it out from a whole big system, then you examine it to see the behavior of that small piece in your software to see how it can help the business, how it can help improve the business. Next is what tools to use, what tools you can use in your software testing, in your unit testing. Unit tests, J one of the testing units you can use is JUnit, and this is I would say a math skill that every software engineer should have or must have. It's a Java library used for unit testing. That is the primary use reason for this software. It is important to understand that this is totally different from your standard Java class library. We use this to further speed up the process of automatic testing for better efficiency. Next is understanding using JUnit for testing. What we can use the JUnit for? We can use it for assertion. And what assertion is that they are used to compare expected values, arrays, single values, objects. And a few examples are like our set equals, like what we have here, our set false, and etc. In the middle right here is basic unit tester. And what this is you wanna what is important in unit testing is you wanna have you want your test name to explain what the test does. And if you if this is done correctly, it's actually very good. That way you don't have to look into your code to see what the code actually does. Just by the name, you are able to know what the code is supposed to do, and it does exactly what it's supposed to do or what it's expected to do. Having good test names is a plus, I would say. And here are a few bullet points to using it. And one way is import org.junit.assert. That is kind of like how you can use the assert part to import an org.junit into your IDE, your Java IDE, or your programming. And you can also annotate with a method like add test, kind of like you have the add symbol with a test following it to do it. And to my right is exception handling. We use this for the most part to kind of like handle when things go wrong. And one of the most popular, I would say, is the index out of bound exception. And we use this most often because it helps handle most of exceptions in your system. It is a specific exception that we use. And the way to do it is you have like add tests, and in parentheses you have expected value equals index out of bound exception to throw an index out of bound exception. And for arithmetic exception, kind of like in the number side, we use like add test expected value equals arithmetic exception. And beneath that, I have an example like int x equals 10 divided by 0. And yeah, I know you all know that dividing by zero is impossible. It's pretty much against the laws of math. So one way to handle this issue or this case is that we use an arithmetic exception. Instead of getting an error just dividing a number by zero, what you get is when you do int x equals 10 divided by zero, this will throw an arithmetic exception. That way, it doesn't cause an error to your programming as you're testing it. It's this helps keep the program running to like throw an exception to keep it running, even though it's dividing by zero, which shouldn't be possible. But with this arithmetic exception, it's possible to do a number divided by zero. And also, the next side is what JUnit can also do is like previously when we do a 10 divided by 0 to try an exception with the JUnit, you can also temporarily ignore some tests, like how when you have a test expected value equals arithmetic exception, what you can do is you can have add ignore on top of the add test, then in parentheses expected value equals the arithmetic exception. And what this is, it temporarily ignores the test, this specific test that you're doing. It temporarily ignores it, and so you can keep it running as well. It's not a full on proof to solve all issues. It's just something you do once in a while. And and I have a few bullet points of what a good unit testing is. First on is to assert your results of code. You want to make sure it's correct, it's right, and there is no mistake in your code. It runs as it's supposed to run. And what you want, as you're doing a unit testing, so you want to make sure you are testing at least, at most, a single unit of work at a time. You don't want to have multiple units. You don't want to be testing multiple units of work, right? You want to do one at a time. This makes it more efficient and better, easy to find bugs and handle them. And also you want to have your at least you want to have your code run fast. It has to run fast. You don't want it to be running like 2 seconds or 3 seconds or 5 seconds. You want it to run at least less than a second, which is why I have like less than 100 milliseconds. You want it to be as smooth, no lag, no delay. It's fast and easy to work with. And you also want to structure what I have is well factored. But what I mean by that is you want it to be well structured, readable, easy to understand. Once somebody look at your code, they can see what it is about and how they can work with it, how they can collaborate with you and help solve any bug or errors in your in the code. If it is not well structured, it makes it difficult to find where the bug is happening, where it's coming from, or what the issue is and how to solve it. You also want to maintain quality test suite to strengthen developer productivity by catching errors and bugs quickly. And above all, you want to make it as simple as you can. Simple is best. Simple is better than complex. You want to make it as simple as possible. Making it complex makes it harder. Again, I want to emphasize it makes it harder for your colleagues or your coworkers to collaborate with you in your code, in your system. The simpler it is, the easier it is for them to test and maintain and manage the code, the system as well. Yeah. Next is marks and stops. And I know a lot of people kind of like confuse what marks and stops are. But in general terms, marks is like separating a code and testing its behavior. Kind of like you separate an entire code from a system and you test its behavior, what it does on its own. Like once you take it out from a system and you test it out, you want to know how it works, how it's functioning on its own. Then you incorporate that to see how it can better function well in your system. While stops is more directed to specific code and nothing else. Yep. What stops is that it ignores any other code and focuses on the one you are testing. Kind of like it is directed to one code, no nothing else. It's able to ignore other codes, and that is pretty much the difference between the marks and the stop. While marks is kind of like separating a code and testing its behavior and its function. Stops is more directed to one specific code, and is able to ignore other codes. The next slide is integration testing. With integration testing, you are able to test the entire system. And this is the stage where I'm not going to go too much into it, but what the integration testing is that you are testing the entire system. Like after you are done with your unit testing, like your exception handling, your naming testing, your assertion, your assertion, and any unit testing for that matter, like ignoring some tests or handling some tests. What the integration testing is you test the entire system as a whole, and doing that is one way I believe it helps to confidently let you know that there's no problem with your code. And of course there's always going to be a problem, but it gives you the confidence that you are able to release or upload your projects for the user or for your clients. And next is software testing, which is another type of testing. In this case, this one is just as the name implies, is it's to test the software pretty much. That's what it is. It's in the software there are bugs, there are errors, there are cases where users are not able to access certain features which they are supposed to. And what the software test is that to it lets the developer be able to test the software and its bugs and errors. That is what the software testing is. And for that, man, I'm done. Thank you.